Okay, so let's continue. So in this example, we have a three-link planar robot, and we are going to use the DH convention to assign frames as well as to be able to identify the DH parameters, so that, as we have discussed from the previous meeting, we want to have the DH parameters in order for us to know the transformation matrices. Okay, so now let's start. So in this example, we follow the DH parameters, the assignment of DH convention, and we say that the joint I axis rotates about the Z I minus 1. Okay, I mean the joint I rotates about the Z I minus 1 axis. So let's open the annotation. Okay, so if this is joint I, and this is joint 0, so let's just have something like Z0 here. Okay, and here will be these should be parallel, Z1 axis. Okay, and remember this is a planar robot. So you'll have another Z axis here that's supposed to be parallel to all the Z axis. So all of these are coming out of the board or coming out of the paper. So this is a Z0, okay, because this robot has 3 axes. And now this is the final, the end effector or the hand, which is Z3. Okay. Now we have already done joint I rotates about Zi minus 1 according to the DH convention. Okay, we have done that. Each joint, in this case here, rotates, this is theta 1. Okay, as joint 1 rotates about the Z0 axis. This is theta 2 as shown there in the, this is theta 2. And here this is theta 3. Okay, as shown in the picture. So this is theta 3, this is theta, I just don't look like theta. Just, okay, that's theta 3, and this is theta 2, and this is theta 1. Okay, so there you go. So now we already identified joint I to rotate about the Z I minus 1 axis. And then we need to know where is our XI. So the XI is a common normal and intersecting both ZI and ZI minus 1. So for the base frame, we can, as I mentioned before, we can arbitrarily assign where are our X and X0 axis, and then the Y0, of course, will complete the right-hand rule. And so in this case, we assign X0 to be in this direction. So let me, okay, X0 to be in that direction. That is X0. So now we say that X0 is common normal to both ZI and Z1 and Z0 axis, as in this both Z1 and Z0 axis. Okay, so of course X0 is already normal to Z0, and so we need to have X1 now to be normal to Z1. So where is Z1? Z1 is in this direction, which is coming out of the paper. And so because that is normal to the paper, for sure X0 is normal to Z1 as well. Okay, remember that Z1 and Z0 are coming out of the paper, and so they are normal to the surface of the paper. And because Z0 is living on the paper, lying on the paper, and so I mean, x0 is lying on the paper, and so z0 and z1 are both normal to x0, okay? And so that is correct. So now we identify where is our x1, and because you know x1 is perpendicular to z1, so we assign, and of course, sorry, we'll look at the origin first. We say that the origin of this, in this case here, is we assign it to be at this point where your x0 intersects your z0, and that is the origin of the zeroth frame. Okay, now let's go to the next frame, which is frame 1. So let's just make this. This is frame 0. Okay, and here will be frame 1. Frame 1. Okay, so we need to know where is your, we already know where is your Z1. We need to know where is your X1. And so we say that X1 is normal, normal and intersecting. Sorry, there is this part here, common normal and intersecting. Okay, let's go back to frame 0. Is X1 or X is XI, okay, sorry, we look at X1, yeah. X1, we say that X0 is arbitrarily assigned, and we assign it there, and it's common normal there. And so now let's go to, it's common normal to Z0 and Z1. And so let's go to X1. So X1 is normal and intersecting to Z1 and Z0, okay? So where is our X1? Okay, now this is how we are going to determine where is the, for frame 1, where is the origin of frame 1, okay? So because we're frame 0, we arbitrarily assign it, and so this is the origin of frame 0, and it is intersecting, of course, with X0 and Z0. But for X1, we don't know where is the origin of frame 1. So now we say that X1 intersects both perpendicular to Z1 and Z0 and also intersecting. So normal and intersecting. Okay, so where is that? So of course we know that as long as X1 lies on the plane of the paper, it is both normal to Z1 and Z0. But we say that it should be intersecting to Z1, and so here, if we place it here, it's already intersecting to Z1. But then we can put X1 here, or X1 there, or X1 here. It is normal in intersecting to Z1, but it is also normal to Z0, but it is not intersecting to Z0, okay? So of all these axes, which one is both normal and intersecting to Z1? Okay. In this case here, all of them, all of these axes, spotlight. So in this case, all of these axes are both intersecting and normal to Z1. And all of these axes are both normal also to Z0 because they're lying on the plane and Z0 is coming out of the plane. But then not all of them are intersecting. As you know, you have normal and intersecting. All of them are normal to Z0, but not all of them are intersecting to Z0. So these two conditions must be satisfied. So in this case now, all of them are normal to Z0, but not all of them are intersecting to Z0. So which one is normal in intersecting to Z0? The only X1 that's normal and intersecting to Z0 is X1. So in this case here, it's normal in intersecting to this X1, is normal in intersecting to Z1, and also normal and intersecting to Z0. So we choose this as our X1. So now when choosing this to be our X1, we identify the origin of the frame 1 to be this point, where it intersects both Z1 and Z0. Okay, so now we identified already the origin of frame 1. So we are going to delete all these other x's that all the other x1s that are not correct. So we are remaining with this x1 now, and so we established our x1 to be this. Okay, so that's already established. So now we say that this is correct for x1, and then y1 completes the right hand coordinate frame, and so we have this is the z, and then this is the x, and to make it the right hand coordinate frame, y1 should be in that direction, and so now we say that y1 has to be we choose a different color, that's blue, green. So y1 to red, green. It should be the colors are not correct. The red, X should be red, and Y should be RG green, and Z should be blue. But anyway, so now we identify Y1 already. So we already completed all these requirements for frame 1. Remember, for frame 0, we arbitrarily choose all those directions. But as long as we are the base frame, okay, we as long as Z0 is the axis of rotation for theta 1, and then the rest of x1 and y1, x0 and y0 can be arbitrary. Okay, as long as they follow again the right hand rule. So x0, x0 should be arbitrary, can be arbitrary, and then the rest y0 follows the right hand rule to complete the frame 0. Now for frame 1, then this is how we are going to satisfy the requirements. Okay, so now we identify already, by satisfying all these 3 requirements, we already identified where is the point of origin for frame 1. And in this case here, the point of origin for frame 1 is this. Okay, and so we are done. So next, let's go to frame 2. So because we already previously identified the axis of rotation. So we know that Z2, how come this is double? Okay, so Z2 this is the Z2 axis, and so now we need to identify where is your X2 axis. So to identify X2 axis, okay, this item 1 is already finished. So let's make it a check. So item 1 is finished. Okay. So for x1, the common normal and intersecting both z1 and z2. Okay. So now again our x2. So our x2 can be somewhere here, somewhere here, somewhere here, anywhere. It can be anywhere. X2 can be here, and x2 can be there, as long as they're both intersecting and normal to Z2. So all of these axes satisfy those 2 conditions, that they are normal because they lie on the plane, and then Z2 axis is coming out of the plane. So all of them are normal to Z2. All of these can be X2. What about the intersecting part? Are they all intersecting to Z2? Yes, they're all intersecting. You know, they're coming out from this point, and so they're all intersecting to Z2. So all of these axes satisfy the 2 conditions of being normal and intersecting to Z2. But then what about normal and intersecting to Z1? Okay, because we satisfy this also. So all of them are normal to Z1. Yes, this X2, we can choose all these X2s to be normal to, you can choose this to be as our X2 because they're also normal to Z1, which is a requirement that we need to satisfy, normal to Z1. But what about intersecting to Z1? Are they all intersecting Z1. No. Okay, this one doesn't intersect Z1 for sure. It goes up here like that. And this one also doesn't intersect Z1 because Z1 is here. This one doesn't intersect. This one doesn't intersect. And this one also doesn't intersect. Okay, the only one that intersects is this one. Okay, this X2 is the one that we choose because it is normal and intersecting to Z2, and also it is normal to Z1 and also intersecting to Z1 because it passes through the point of origin of frame 1. Okay, and so this is the correct X2. This is what we choose. Now let's undo all those annotations. Okay, so we identify our X2 already, which is that both normal and intersecting to X2 and normal to X1. X2 is normal and intersecting to Z2 and also normal to Z1, and also it is intersecting Z1 because it passes through the point of origin of frame 1. So now let's finalize our frame 3. So I mean frame 2 origin. So that is our frame 2. Again, once you identify X2 axis and Z2 axis, you already know the origin of your frame 2 axis, and now you know where Y2 will be to complete the right-hand rule. Again, that is X2 coming out, I mean Z2 coming out, X2 is that direction, and so Y2 is in that direction for the right-hand rule, and so Y2 will be in that direction. Okay? So now, what happens to the n effector? How do we find the x1, x in this case x3 and y3 directions? Okay. So again, we go through. We say that x in this case here z3 we set to be here, but actually z3 we can choose z3 not to be here because there's nothing rotating in the hand anymore. It is just the tip of the hand. But just for easy convention, we normally, just so you can, just for ease of imagination and ease of computation, to have lesser parameters, I mean lesser numbers to deal with, and there are many zeros in your matrix. So we arbitrarily assign Z3 to be parallel to Z2. That is what most everyone is doing. And so now, because Z2 was coming out of the paper, Z3 can be coming out of the paper. And the origin is at the tip of the hand, because that is where the frame of interest is. Because that is where we manipulate things when we attach to the hand. And so we identify the axis of origin of the n effector will be somewhere here at the tip of the hand. What about the x? So again, x must pass through the Z3 axis and intersects the Z3 axis and is perpendicular to the Z3 axis, as well as perpendicular to Z2 axis and perpendicular to Z2 axis and passes through the Z2 origin of the Z2 reference frame. Okay, so now we can say that X3 can be here because X3 satisfies that condition. Okay, so we get, so as a rule of thumb, we can say that normally we put the n effector frame at the tip of the hand, and the Z axis, Z of the n effector is parallel to the Z of n minus 1 reference frame, and then the X3 axis follows that rule that it intersects Z3 axis as well as Zn axis as well as the Zn minus 1 axis. Okay, so now we completed all the requirements for the origin of the reference frame, and so we say that this is now frame 3, and that is its origin, and we have identified it. Okay, so because now we have identified all those reference frames, we are ready to identify the parameters, the DH parameters. Okay, so let's go here. I cannot scroll. I have to end annotation to be able to scroll. So, okay, there. So now, okay, I need to delete those. Okay, let's go back to annotation. And I want eraser, big eraser. Hey, I thought I can erase. Undo. Eraser. I cannot make a bigger eraser. Okay. Cannot make a bigger eraser. There. I can just erase like this. Okay. Okay, there. So now, let's check on how to assign, identify your 4 parameters for each joint. Okay, so let's start with joint 1. So in this case here, let's look at here. Okay, this is joint 1 or link 1. Okay, so for link 1, this is link 1 and that's joint 1. Okay, so this is link 1 and that's joint 1. So what is theta 1? Theta 1, we say is that theta 1 is about zi minus 1, that means z0, okay, from x0 to x1, okay? So x0 is this 1 and this is your x1, okay? So x0 to x1 about z0. So about z0 by right-hand rule, you go from x0 to x1 like that. And so going from here to there, from x0 to x1, that is positive theta 1. So we call it, so we have theta 1 here. In this case, let's do it again, draw it again to make it more clear. So this is theta 1. Okay, that is theta I and this is theta 1. Okay, so that's theta 1. What about alpha 1? Alpha 1 is about x1. Okay, alpha I about xi, so alpha 1 about x1. So where is x1? This is x1. And we say it is about x1. So x1 about x1. So you use again the right-hand rule. So x1 in that axis, in that direction. And so going in this direction is alpha. So from Z0 to Z1. Where is Z0? Z0 is coming out of the paper like that. And Z1 is also coming out of the paper. Is there any rotation from Z0 to Z1 about X1? No, because they're parallel. Okay, there's no rotation and so it will be 0. So here, that's why this is 0. Okay. And this is theta 1. We finished already. Next, let's go for distances. So D1 along Z0 from origin of frame 0 to intersection of Z0 and X1. So I modified the description of the DH parameters here for easy understanding. Okay, so these are much better to understand compared to those that are in the books. So we can see here that about, meaning to say that those are the angles, and then along will be the distances. Okay, and then in this case here, we start with about so that we know that it's rotating from that particular axis, and then from a certain axis to another axis. So that we can have an analogy. So here, this is a better analogy now because we specify the axis of rotation and from one axis to the next axis. So now this is much more pronounced. This analogy now is much more pronounced when we look at distances because distances normally is difficult to interpret. So D1, in this case, D1 and A1 are distances. So along Z0, okay, from one origin, from the origin of the I-1 frame to intersection of these two axes. Okay, let's start. Where is so along Z0, so along Z0, this is Z0, okay? From the origin of the frame. So the origin of the frame is this one. Let me annotate that so that we can see clearly. So I use brown. Is it, can maybe pink so that it will be very clear. So this is the origin. Yeah, this is x-axis and that's the origin. So along this axis, I mean this is z-axis from this in this origin. So along z-axis from that origin to the intersection of z0 and x1. So where is x1? This is x1. An intersection of z0, that is z0. So the intersection is this, okay, which is coincident to the origin of frame 0. And so there's no distance, okay? The distance is 0. The distance along this axis from the origin of frame 0 to the intersection of x1 and z0 is this. And so there is no distance, and so A0 or A1 is, this is supposed to be, oh, sorry, D1 is 0. Let's undo that. D1 is 0. Okay, that one is 0. Okay, sorry, I was referring to, we are looking at D1. So now if we look at A1, A1 is along X1. So where is X1? So this is X1. Okay, so along X1 from intersection of Z0 and X1. Where is intersection of Z0 and X1? Again, the intersection of Z0 and X1, this is the intersection. Okay, to origin of frame 1. So where is the origin of frame 1? This is the origin of frame 1. Okay, from here to here along X1. So X1 goes in that direction. So now we see that the direction is important. So it will dictate whether there's a positive and negative sign. So in this case here, from here, X1 from here goes towards this direction. And so that is a positive sign. And so the distance from here to the origin, this is A1. As you can see, it's already labeled A1. So that is, and it is positive. It's along A1 from the origin of, from the intersection of Z0 and X1 to the origin of frame 1 along in that direction. And so it's positive A1. And so we say that this is A1. Okay. Now let's go to the next joint. We say that this is joint 2. So let's start with joint 2. And we say that, let's go and check for all these parameters here. Let's start with theta 2. So theta 2 about Z1, okay? So this is Z1, okay? This is Z1, and we say that about Z1, so Z1 is going in that direction by right-hand rule, from X1, okay, because we are looking at theta 2, Z1 from X1 to X2. Where is X1? X1 here, and X2 is there. Okay, let me, I hope you can see that spotlight. Okay, this is X1, and X2 is there. About Z1. So about Z1 from X1 to X2. So in this case, from X1 to X2, that's a positive direction. And so this is now your theta 2. And so we say that we identified theta 2. So let's make it blue. Okay. Let's check one more time. About Z0, I mean, about Z1 for theta 2, about Z1. So this is Z1. Okay, about Z1 from X1, from here to, from X1 to X2. X2 extends up to here. Okay. Okay. And so remember, this X2 intersects with Z1. Okay. So from here to there, and so that is your theta 2. Or why is that theta 3? It should be theta 2. Okay, let's delete that one. That should be theta 2 and theta 3 is over here. Ah, no, that was correct. It was this one. Okay, wait. Let's undo. Is theta 3 because I'm looking at this extra. Okay, sorry. The theta 2 is here and that is theta 2. Yeah. So it's my mistake. Theta 2 should be here because this is, I didn't see that this is for Z3. This is for Z3. So this is the one that's wrong. So this is, we should change this one. So there's less confusion. Oh, yeah, this is Z2. That's correct because it is double. Okay, anyway. So now let's go theta 2. Again, let's review that because there was some misunderstanding about this theta 3 and Z2. So now we have theta 2, we have around about Z2 from X1 to X2 using the right hand rule. And so this is theta 2. And so we're done with theta 2. We already successfully identified that. Alpha 2. Alpha 2 about X2. So where is X2? So this is X2. Yeah. About X2. So if X2 is going in that direction, and so we, by right hand rule, the thumb is your X2, and then you rotate about that X2. About X2 from Z1 to Z2. Okay, excuse me. So where is your Z1? So this is X2. Yours, this is your X2. I'm afraid that the recording cannot see the mouse. And so here, this is your X2. So about X2 and from Z1 to Z2. So because this Z2 axis, these two axes are parallel, so there's no rotation with respect to X2. And so your alpha 2 is 0. So we already know alpha 2 is 0. Okay, again, X2 in Z direction, and then Z1 and Z2 are both parallel. There's no rotation about X2, and so alpha 2 is 0. Okay, now D2 along, so this is D2 along Z1. Okay, where is Z1? This is Z1. Okay, we're looking for D2 along Z1 from origin of frame 1. So frame 1, this is the origin. Okay, this is the origin. Okay, let's make it 0. Make it pink. This is the origin. From origin along Z1, origin of frame 1. Okay, this is along Z1, origin of frame 1. That's the 1. From origin of frame 1 to intersection of Z1 and X2. Z1 and X2. So where is X2? This is X2 intersection with Z1. So X1 and X2 and Z1 intersection, that is the 1. So origin of frame 1, this is also that one. Okay. So along Z1 from origin of frame 1 to intersection of Z1 and X2. The point of intersection is this, is the same, is coincident with the origin, point of origin of frame 1. And so your D1 is 0. Okay, again, finish that one already. D1 is 0. Lastly, your A2. So your A2 along X2. So this is your X2. Spotlight. So this is your X2. And then along X2, from intersection of Z1 and X2. So X2 and Z1, this is the intersection. Okay, this is the intersection. Maybe that's the intersection. And then intersection of Z1 and X2, that is the one, to origin of frame 2. Where is origin of frame 2? This is the origin of frame 2. Okay? So again, along X1, let's spotlight that one. Along X2, for A2 along X2, from intersection of Z1 and X2, this is that intersection, to origin of frame 2. From here to there, along X2. X2 is going in that direction, so this is positive. So from here to there, the ray of X2 is going in that direction, and so we are going towards the positive direction of X2. And so we call this distance our A2 now. Okay, so that is A2. Okay, we're done with frame 2. Okay, now let's go frame 3. Okay, so frame 3 or link 3, yeah. So link 3 is rotating about Z2, yeah. So now this is your Z2. So let's identify now your theta 2. So if you have theta 2 about Z2, this is Z2. This is your Z2. And from X2, this is your X2 to X3. So that's X3. So we're looking at theta 3 now. This is theta 3. Rotates about Z2, and that is your X2 towards X3. From X2 to X3, rotating about Z2. And so this is your theta 3, and that's positive. From X2 to X3, rotating about Z2. This is Z2, rotating from X2 to X3. This is your theta 3. So now we are done with theta 3. That's okay. So we put this one like that. Okay. So we're done with theta 3. Now let's go to alpha 3. So alpha 3 is about X3. So where is X3? That is X3. Let me do the spotlight again. So that is X3. About X3 from Z2, Z2 is this, and to Z3, okay? So you rotate about X3. So X3 is that axis of rotation, and then you use it as the tip of your, as the thumb direction. So thumb direction. So your Z2 to Z2 to Z3. So Z2 and Z3 are going in that direction out of the paper. There's no rotation because they are parallel. Both of them are parallel, Z2 and Z3, and so there's no rotation about X3. And so your alpha 3 is 0. So we're done. Alpha 3 is 0. Alpha 3 is 0. Okay. Next, let's do D1. So along, okay, sorry, we do D3. Yes, D3. Along Z2. Where is Z2? Z2 is this one. We identify D3 along Z2 from origin of frame 2. So again, let's draw the origin. Let's draw it. Or maybe we'll put it square so that this time we can differentiate it. So from the origin of frame 2, okay, origin of frame 2 to the intersection of Z2 and X3. So where is Z2? Z2 and X3 is this. Their intersection is also the same. So let's make it a different color. Okay, that's also the intersection. Okay. The frame of origin of frame 2, which is that, and the intersection of Z2 Z2 with X3 is the same point. Okay, and so your D3 is along Z2. There's no distance because those 2 points are coincident. Okay, so this is a 0. It means your D3 is 0. Okay, any questions? So after that, let's finally look for A1. So I mean A3, sorry. I always have this problem with indexing the numbers. So when I'm looking at, let me put on my icon. We're looking at A3 now. So along X3, where is your X3? X3 is in that direction. Along X3 from intersection of Z2 and X3. So Z2 and X3. This is Z2 and that's X3. The intersection is here. So let's draw it one more time and then make it a different color. Okay, that is the intersection. Okay, intersection of Z2 and X3 to the origin of frame 3. Origin of frame 3 is this. Okay, and you are along X3. From this intersection, Z2 intersection of X3, from this point, the origin of frame 3, which is this point along X3. So from here to there, okay? So this is in the positive direction of X3. And so this one to there is positive, and so this A3. This is A3. This distance is A3, and also it's positive because it comes from this point, it starts from this point, along in the direction of X3, positive direction, and so this is A3. We identified A3 already. Okay, finished. Okay, now let's, that is one example, okay, of a 3-planar robot. Now we identified all by DH convention. Using the DH convention of coordinate frames, we set all those frames. Where are the directions of your Z-axis and X-axis, the ZI and XI axis, and then the YI axis completes the right-hand rule. That's how we followed to here. And then once we identified how the frames are being assigned, attached to each of the joints of the robot, then we identify the DH parameters, the 4 DH parameters, theta I, alpha I, DI, and alpha and AI. So now, after attaching the reference frames, we identified all the 4 parameters for each joint or for each link. So we identify all those. And so now, after all these are identified, after all the DH parameters are identified, now we will already know how to compute the transformation matrix. Okay, as we discussed earlier, the transformation matrix takes a certain form. In this case, this is the total transformation matrix where you have Z, a distance Z, a D along the Z axis, transformation distance along the Z axis. Next is a transformation matrix, the translation along the Z axis, and the DI, translation, rotation about theta by Z axis. So this is rotation about Z axis. Let me annotate again. Just to emphasize. So as we know, this is the rotation matrix, and this is the position vector. So because this is purely translation, so this is just identity matrix because there's no rotation, purely translation of D, distance along the Z axis. Okay, so this is the first transformation. Now we transform by rotating about Z axis. Okay, so this is the rotation. There's no position change, it's purely rotation. Rotation about Z-axis, we discussed this one already. That rotation about Z-axis is 1 here and 0, 0. And here will be cosine theta, cosine theta. and sine theta and the off-diagonal terms, and this is negative here and it's positive. So this one is the rotation about z-axis of theta value. Next, translation of x by a value. So here, purely translation, no rotation, so that's identity matrix. And here, this is the translation or the position transformation and a value of a, okay, of ai. So the rest of them are 0, so that's a third transformation. The fourth and final transformation is that rotation of alpha about x. So this is purely rotation, no position change, rotation around x. So this is 1, and these are all zeros. And again, this is by alpha, so cosine, cosine. These are the cosine of diagonal terms, and of diagonal terms is negative here, sine, sine, and negative. Okay, so those are all the 4 transformations. Okay, and now the total transformation is this. And then if we substitute all these values for each joint, okay, in this case, instead of having a complete transformation like this, because it is a planar robot, the result is a simplified transformation like this. Because as you can see there, alpha is 0 and d is 0. For example, here, alpha is 0. Let's check. Because alpha here is 0, what will happen? Okay, that's 0. Or it's not 0. Sine, okay. Where is that? Alpha is 0 here. Let's undo. So this is the, sorry, this is the inverse. Okay, so this is the inverse, sorry. This is the result. Okay, let's undo this. Okay. How come there's an alpha? How do I erase this? So I erase it first. Erase, erase, and I keep doing this because there's rotation. Okay, the result is this one. Sorry, this is the result. This is the inverse of that result. Okay, let's look at here. So now you have cosine A, you have values for A, yeah, A1, A2, A3. So here is correct, A1 and cosine theta are variables, so you have this. Your D in all is 0, so this is 0. And so now this is 0, so this is 0. So this is 0 for all, because all your D is 0. So all the transformation matrix like that. So your alphas are 0, so sine alpha, sine of 0 is 0. So this is 0 and this is 0, so that's why this is 0 and that's 0. Cosine of 0 is 1 all the time because these are all 0, so that's 1. Okay, so it simplifies this one. And now your alpha is 0 because you always have cosine alphas here. And so that is 1 and that is 1. And so you're left with minus a sine of theta I and cosine of theta I. Okay, and here cosine theta, sine theta. So it results into this much simplified transformation matrix because it is a planar robot. Okay, so now because this is we just substitute all these parameters here, and so excuse me, to get the transformation from the base frame to the third frame, from the base frame here. Okay, let's okay, maybe from the base frame here to the end effector frame here. So you have transformation from the base frame to the end effector frame, base frame to the transformation of base frame to the first frame, and post multiplied by transformation of frame 1 to frame 2, post multiplied by transformation of frame 2 to frame 3. And so we see that this is somehow, we discussed this last meeting, somehow there's a cancellation. Cancel this and cancel this, 1, cancel 1, cancel 2, and cancel 2. So it becomes transformation from the base frame to the third reference frame or to the end effector frame, which is this. And so now this is the total transformation for the planar robot. So with this, what we say is that we know what is the orientation given these parameters, I mean, given this transformation matrix, we know what is the orientation of here. That's the orientation of the n effector frame with respect to the base frame. Okay, and this is the position of the n effector frame with respect to the base frame. Okay, let's interpret this. Okay, so it looks like here the rotation is very simple, you know. So it rotates about z-axis all the time because this is 1 and the rest of them are 0. That's true because the z-axis, as you can see, it's always coming out of the paper. The z-axis are coming out of the paper. All the axes are parallel and all of them are normal to the paper. Okay, because all of them are normal to the paper, they have to be parallel. And so the z-axis remains, I mean, the z-axis, this rotates, everything rotates about the z-axis. This is normal to the paper, and so this is 1 and the rest of them are 0. And so because of that, we only need to know the total theta 1, the total angles, theta 1, theta 2, and theta 3 rotation of all the joints. They add up. In this case here, it becomes a simple cosine, say theta 1, theta 2, theta 3 in the diagonal terms to know the n effector rotation, and then off diagonal terms are minus sine and sine of theta 1, theta 2, and theta 1 plus theta 2 plus theta 3. Okay, so normally this is the convention of, we say if this is sine 1 to 3, like that, and we know that theta 1 in this case, theta 1, theta 2, theta 3 are all the variables. Okay, all of them, the distances a1, d1, and alpha. So in this case here, because the robot is a rotation, it has a rotationary joint, or all the joints are rotationary, then the variable here, normally there's only one variable. Okay, if it's a rotary joint, the variable is this, theta 1, theta 2, theta 3. If it's a translational joint, or like a prismatic joint, that's what they call a linear joint that translates, okay, it can be, depends on, I think normally it is A1, I think it is A1, that is the variable. I'm not sure if D1 can also be a variable. I'm not familiar with it, but yeah, it's either A1 or D1, yeah. So because I think one of it, yeah, it cannot be, it just like theta 1 here. Theta 1 is always the axis of rotation. And okay, let me just check just to be clear about that, because it's along the z-axis. Okay, we say that it should be D1 because a z-axis is about the z-axis. This is the variable. So the z-axis, we move along the z-axis. So D1 should be the variable. Okay, let's correct this one. So where's the annotation? It's not coming. Okay, so let's delete first. So the variable should be D1. Okay, if it's not D1, it is theta 1. So in case these are, if it's D1, if it's again, if it is D1, if it's a prismatic joint, that means it's a linear joint. You know, for example, you have joints that are pneumatic joints, okay, or hydraulic joints that are moved by pressure, okay, or you have gear that makes from a rotary joint to a linear motion, like that. So now you have a linear motion or linear translation for each joint, and so D will be your variable, DI will be your variable. In our case here, theta I is a variable because the joints are rotational or rotary joints. So normally, it goes back to what I want to say regarding 1, 2, and 3, because in this case, theta is the variable. So here, 1, 2, and 3, it means theta 1. Okay, let me write it down here. Okay. Q1, I just say Q1 because I cannot write in terms of Q is equivalent to theta. So Q2 plus Q3. Okay. When you have C1, 2, 3, for example, is equal to that. Okay. Okay. I cannot undo. So let me undo. Make it bigger. There. So C1, 2, 3 is equal to cosine of Q1 plus Q2. Okay, that's a normal convention that people follow, and sine 1, 2, 3, just for to cut the notation shorter. Q1 plus Q2 plus Q3. Okay, it's like that. So 1, 2, 3 is an addition of all the thetas, theta 1, theta 2, theta 3, in this case Q1, Q2, Q3, and C is the cosine, and sine 1, 2, 3 is S1, 2, 3 is sine of the addition again of theta 1, theta 2, and theta 3. Okay, so now we already, after following all the DH parameter, DH convention on assigning the reference frames, the axis and the reference frames origin, now we're able to identify all the 4 DH parameters. And after identifying all the 4 DH parameters for all the links of the robot or the joints of the robot, then we will know the transformation matrix, which is the relationship of the previous joint, I mean the I minus 1 joint to joint I. That means the previous joint to the current joint. And so after knowing this relationship between reference frames or between joints, then we will be able to find the total transformation from the base frame to the end effector frame. In this case here, because the robot is quite simple and there are just 3 links, and so here the transformation matrix is not that complicated. Okay? Okay, now let's go to the next example. So let's clear all the drawings and all the annotations. Okay. Now let's go. Clear that. And next slide. So a spherical arm. Okay, let's check the spherical arm and then we follow again these conventions. Let's go through all these examples so that you will be familiar with them. Okay, so now a spherical arm is like, they called it a spherical arm because the motion of the end effector mimics a motion of a sphere. Like you go through, you create a sphere. Okay, you go through all the points in the sphere. Okay, so in this case here, it has 3 joints, and it will be able to point to or to locate to all the points in the sphere as a solid sphere. Okay, compared to looking only at the shell of a sphere, for example. If you want to draw like a shell of a sphere, it will be similar to pan tilt joint. Pan tilt is that the joints that rotates and the other one only tilts. So it pans and it tilts. So in this case, if pan tilt joint draw the shell of a sphere, in this case, depending on how much the tilt can do, it can draw a hemisphere. Okay, the hemisphere like that. It can draw. It can reach the shell of the hemisphere with a radius equivalent to the arm, the radius of the arm. Okay, the radius of the arm of this tilt arm. Okay, that's a pan tilt joint. In our case here, this is it's almost like equivalent to a pan tilt joint, but in the last joint, because pan tilt only has 2 joints, one to rotate and one to tilt. Yeah, And the third joint, to make it to be able to reach to different points within the volume of the sphere, this last link will be able to slide through. So this is the one that slides through. Then it reaches, instead of drawing only the shell, for example, if this is the only one that moves and this one moves, it draws a shell. But because this one also moves, then it draws a certain volume about the sphere. Okay, so let's do assign the frames here and also identify the DH parameters. So in this case here, we have 3 joints. So one joint rotates. Okay, let me. Okay, so one joint rotates about here. This is theta 1. Rotates about that axis. And this is theta 2. Okay, that's bad. Okay, that's theta 2 and rotates about here. That means it's positive in that direction. Okay, and theta 3, it's not theta 3, it's D3. D3, okay, so D3 is the one that moves up and down. So that is Z2 and D3 is here. So in this case, the variable is D3. Okay? Okay, now, so, okay, I thought this is the one that moves along, but this is the one that moves. Okay. Anyway, so it's still the same. It can still reach to different points within the volume of that particular sphere. Okay. Now we say that joint I rotates about Zi minus 1. So in this case, joint theta 1 rotates about Z0. So Z0 is here. So let's follow the convention RGB, red, blue, and green. R is red, green, and blue. So blue is the Z-axis. So we make it the Z-axis, make it blue. Okay, so that's Z0. Okay, sorry. Let's make it nice now, because we have achieved certain understanding. So that's Z0, and theta 1 rotates about Z0, and that's the rotation of theta 1. Okay, and then, okay, again, joint 2 rotates about Z1. So where is Z1? Okay, Z1 is this. Okay. I cannot answer because I'm recording. Okay, so that Z1, and then Z1, theta 2 rotates about Z1. That's the case. And then now, in this case here, joint 3 rotates or translates about Z2. So where is Z2? This is Z2, and joint 3 translates. In this case, it translates in that direction. And so this is joint 2. Okay. I mean, joint 3, sorry, that translates along Z2. And then, as we mentioned before, because the n effector, this is the n effector. The n effector we can put arbitrarily. Okay, if we say that there's a certain arm here, this one extends through here, and this is the length of the arm, and this is where the hand is. We can draw. Just say, for example, this is where the hand is. Is where the hand is, yeah. So we can say that this is the n effector. We choose our n effector to be here, okay, because that is where the hand is. So now we identified already the axis of translation and rotation. So now we have xi is a common normal. Let's go back to identify x. Yeah. So we identified already the axis, the direction of Z0, Z1, Z2, and Z3. Okay. But we don't know where are the x's. So the X0, X2, X1, X2, and X3, when once we identify that where is the direction of X of these x's, and then the intersection between this X and the corresponding Z axis will determine the point of origin for that particular frame. Okay? So now, as we mentioned before, we say that we can arbitrarily set your Z0 to be, X0, the origin of the base frame to be somewhere. Okay? So in this case here, I think to just look at what they did. Okay, never mind. I can choose because, okay, let's do the exercise of saying that I choose my Z0, X0 to be somewhere else. Okay, so my X0, I will do it somewhere, and R is red. Yeah, so I want my X to be here. This is my X0. Okay, and we say that X0 is this one, X0. Okay, that's what I choose. Okay, so that is my Z0, X0, and by right-hand rule, that means your Y0 is here. So R green, eh. Okay, so that is your Y0. In this case, this is your Y0. Now, we completely identified where is our origin. Okay, now, next, again, we can arbitrarily set the X0. I choose X0 to be there and Y0, so it completes the right-hand rule. Finished. So now let's go to joint this joint one. The rotates about that, and so let's just write it down first. So this is where your frame 0 is. Frame 0, and that is the origin of your frame axis. We say the origin, and we put it pink because this we can see properly. That's the origin of your frame 0. Okay, now we're done with that one. So let's look at joint 1. Joint 1 rotates about Z0. So this is your theta 1 rotates about Z0. Okay, so next we look for the origin of frame 1. This is frame 0 and frame 1. To look for the origin of frame 1, we need to identify where is Z1. So we know already that Z1 is here. Z1 is there, and this is Z1, and your X1 we don't know. Okay, so where is your X1? So X1, we say that is a common normal and intersecting to both Z1 and Z0. Where is Z0? This one. Okay, and this is Z1. Yeah, and as you can see, Z0 and Z1 are intersecting already. Okay, and in this case, they are normal to each other. Okay, so common normal. Okay, they're normal to each other. That means they live in a particular plane. They live in this plane. In this plane. Z1 and Z0. So we choose our X to be normal, our X1 to be normal to both Z1 and Z0. That means it should be normal to that plane. Okay, normal to that plane and intersecting both Z1 and Z0. So there's no other axis except this particular axis where both Z1 and Z0 intersects with each other. And so X1 has to pass through that point, as well as it has to be normal to those two axes. So that means that X1 has to be in this direction. Okay, this direction of x1. I mean, x1 has to lie in that line. But which direction? So in this case here, we can choose going inward towards the paper or outwards toward the paper. So for the author, it choose to be, okay, let's just follow the author and red, yeah? We choose our x1 to be in that direction. There, that is your x1. So now that is your x1. We follow what the author is doing. x1. x1. That is, it's not nice. Okay, it blocks the key here. x1. Okay, there. So that's our x1. We follow what the author is doing, and so by saying that x1 is here, then we know already where is the origin of frame 1. Okay, we draw it, and you see in the pink. That's the origin of frame 1 because there were x1 and z1 intersects. Okay, so now we know that is the origin of frame 1. Okay. Okay, and because by right-hand rule, where can y1 be? So x, x and z is going that direction. That means that y1 will be in this direction. Where is that? And green. So y1 has to be in this direction. Okay, x, y, and z1 there. So this is y1. Okay, we finished already. Next, we identified frame origin of frame 1. Yeah, so now we need to identify origin of frame 2. Okay, so frame 2, we already know that z2 axis goes in, z2 axis in the direction because that is where the translation of this prismatic joint is ongoing. So this is z2. We need to know where is x1. I mean x2. So again, x2 is a common normal and intersecting both z2 and z1. Okay. So where x2 can be both intersect. Where is z1? Z1 is this, and this is z2. Z2, okay. X2 has to be normal to both z2 and z1. So z2 and z1 is this. So again, they live in that plane. Okay, this particular plane. That is where z2 and z1 lives. And so x2 then has to come out of that plane or going inside that plane. Okay, so it x2 again, x2 can leave through here, but then can leave through in the same direction as x1, but then it has to intersect both z2 and z1. For x2 to intersect two lines at the same time, okay, that lives on that particular plane, okay, it has to intersect there. It has to intersect those lines where the two lines intersect themselves in order to hit them at the same time, okay? So now it constrains our x2 to be at this, passing through this point in order to intersect both z2 and z1, okay? Again, because z2 and z1 lives in this plane, we know that x2 will be coming out of that plane or going inside that plane as long as it is parallel to those arrows. So that means that it could be also in x2 can be here, x1 can be anywhere, somewhere, as long as it passes to that plane. But because of the second requirement, that it is just not normal, it has to be normal, but then also intersecting both z1 and z2. So to intersect both axes, x2 and z2 and z1 at the same time, that leaves those two axes lives on the same plane, then it constrains x2 to be intersecting, to be passing through the point of intersection of Z2 and Z1. And so that's why X2 has to pass through this point. Okay, again, let's say that, okay, not green, and do pink first because that's our convention. So X2 can be like that, yeah? In that direction, going outside here or going inside there. But let's just choose the convention of what the author did. So let's choose our X2 direction. The direction can be arbitrary, okay? So let's choose our X2 direction to be in that particular direction, the same as what the author have chosen. And so we know that our X2 is there. That's X2. Okay? So now, I'm still not done with time. So that's our X2. So now we identify the origin of our frame 2 to be here, where X2 and Z2 intersects. Okay? And so we choose our origin now to be here of frame 2. And because of that, our Y2, where is our Y2? Because Z2 is here, that means our Y2 is in that direction. So why they have the Y2 here, but it didn't show the Y1? Okay, anyway. That's the Y2, and this passes through that origin, so Y2 is there. So we write Y2. Okay, now we complete already frame 2. Again, frame 3, normally we just make things, Z will be along in the same direction, Z3 will be in the same direction as Z2, and then X will be parallel to the same X, is just translating along the Z axis, and assuming in this case it's not shown, but assuming that the hand is here, so we choose the origin of our, normally at the end effector, we choose the origin of our reference frame to be this one, and Z3 is along Z2, and that is the origin. So that means we can also choose to arbitrarily say that X3 is parallel to X2, and so in that case Y3 can become parallel to Y2 as well. Okay, so now we are done. We already have chosen where is your frame 3 origin. Finish. Okay, so now we identify the other parameters. Now I cannot scroll without, I can scroll. Okay, okay, I just delete those, this one and this one. Okay, so now I can scroll. So we identify theta 1, theta 2, theta 1, alpha 1, D1, and A1. Okay, the DH parameters for link 1 or for joint 1. Okay, so we know that theta 1, it rotates about Z0. So where is Z0? That's Z0. Okay, and from X0 to X1. Where is X0? Let's just spotlight. Where is X0? X0 is in this direction, and X1 is in that direction. Okay, X0, X1. Okay, about Z0. That's Z0. So that means there's no rotation from X0 to X1. Okay, so that is 0. Okay, in that case, it is 0, but because it is a variable, in this configuration, it is 0, but because theta is our variable, we put it theta 1. Okay, we don't put it theta 0. Okay, the reason why? You know what's the reason why? The reason is because, again, it is changing, yeah? So it can change value anytime. If you put 0, then it will remain 0 all the time. But because it is a variable, we put it as a variable. It's just 0 here because of that particular configuration of variable. As this theta 1 moves, and then x1 will move with it, frame 1 will move with it, and so now there will be changes in the angle between x0 and x1. Okay, so now let's go alpha 1. Alpha 1 is the about x1. Okay, where is x1? That is x1. This x1 from z0 to z1. Where is z0? Z0, and that's z1. Okay, so about x1. So x1 now is the axis from z0 to z1. So it's like that. This is it, because z0 is on top and x1 is going, I mean z0 is on top and z1 is going this. So it's a negative direction. So negative, this is 90 degrees. Okay, from x1, about x1, so z0 to z1, that's a negative 90. So that's why alpha, this is 90 degrees, is pi over 2, and it's negative. Is that clear? Okay, because now, as you can see here, the rotation about zx1, this is positive. That's the positive direction. But because from z0, from here, going to here, okay, that's in the opposite direction. So that's why it's negative pi over 2. Okay, so along, now D2, along Z, D1. So, sorry, let's annotate this one. This is done, and that's done. Okay, D1, along Z0, yeah? D1 along Z0. Along Z0, so that is Z0. That's Z0. From origin of frame 0, so origin of frame 0, to intersection of Z0 and X1. Intersection of Z0 and X1. That's the intersection of X0 and intersection of Z0 and X1. So that is Z0 and this is X1, that is their intersection. Origin of frame 0. So we choose our frame 0 to be here. Okay, so along Z0. So that is the positive direction from here to there. Okay, that's positive direction from here to there. Okay, so that is D1. Okay, now their D1 is 0. Why? Okay, because they choose their frame 0 to be here. Okay, I choose my frame 0 to be here, and so that's why there's a distance there. Okay, so now I don't put a D0 there, I put a D1. Okay, let me put a D1. So this one is not anymore applicable. Okay, instead we put D1. Okay. Okay. Okay, there's a D1. Along Z0, from origin of frame 0 to intersection of Z0 and X1. This is the intersection from here to there. Okay, and it's positive direction going towards Z0. I mean, Z0 direction is positive, and so that's our D1. Okay, is that a variable? No, that's not a variable. That's a constant. Okay, and why is it 0 for this example? Because they choose their reference frame 0 to be coincident to here. Okay, for simplification. But for us, just for our exercise, we choose it to be here, and so we say that now there's a D1 instead of a 0. So along, we're looking at A1 now. A1, along X1. So along X1, from origin of frame, along X1 from intersection of Z0 and X1. Z0 and X1 intersection is that one. Okay, let's do again, and then we'll put yellow. So that's the intersection of Z0 and X1 to origin of frame 1. Origin of frame 1 is also the same, and so now they're coincident. Okay, it doesn't matter which axis you are computing it from, but the points of origin are coincident, and so the distance is 0. So that's 0 now. That's correct. Okay, so the only difference that we have is that the D1. So next, let's do, I wonder why the time is still, okay, anyway, it's 40 minutes, I know Zoom has 40 minutes. And so now, let's go to link 2. So link 2, so theta 1 about Z1 from X1 to X2. So where is Z1? Where is Z1? Let's highlight that one. That is Z1. Okay. About X1, so that's your, oh no, you're looking at theta 2. About Z1, so Z1, about Z1 like that, from X1 to X2. Where is X1? That's X1. And X2 is this. Yeah. And so X2 and X1 are parallel. Okay. And we are looking at how X1 and X2 change with respect to rotation about Z1. In this particular configuration is 0. But because our theta 2 is variable and it rotates about Z1, and so we don't put it 0, but we put it theta 2. Because that's a variable, although in this case it is 0. But if we put it 0 there, it will always be 0 and it won't change. So we have to put the variable theta 2 there. So now this is theta 2. Okay? So again, it is about Z1, which is about this Z1 from X1 to X2, but X1 and X2 are parallel. There's 0 angle between them, but because theta 2 is a variable, so we write it theta 2. So this is done. Alpha 2. About X2, where is X2? X2 is this one. Okay. About X2 from Z0 to Z1. Okay. That is Z0 to Z1. Okay. About X2. Correct? Yeah. So that is Z0 about, sorry. Correct? You are looking at alpha 2 about X2 from, okay, sorry, Z1 to Z2. Where is Z1? Z1 and Z2 is up. Yeah, sorry. So Z2 is here. I mean, Z1 is here and Z2 is there. So about X2. X2 is in the direction from this one, from Z2, Z1 to Z2. And that is positive. Okay, positive 90. So let's look at this again. So that means it's rotating about this one. Okay, rotating about that X2 and Z1. Let me just change the color. You can extend Z1 here. Okay, that's Z1 and moves toward Z2. Okay, that's why it's positive 90 degrees. Okay, so that's the reason why it's positive 90 degrees. Okay, so we're done with angles. Now we'll do distances. So distance along, okay, we're looking at D2. So along Z1. So along yeah, we're looking at D2 along Z1. So where is Z1? That is Z1. Okay. From origin of frame 1. Origin of frame 1 is that. Origin of frame 1. Okay. To intersection of Z1 and X2. So where is Z1 and where is X2? So this is the intersection. Okay. So from origin of frame 1 to intersection of Z1 and X2, this is the origin. This is the origin, and this is the intersection of Z1 and X2. That's the intersection along Z1 axis. So Z1 is in that direction, so this is a positive direction. So from here to there, that's a D2 and it's positive. So there we have a D2. D2 is done. Okay, what about A2? Along X2. So where is X2? This is X2. From intersection of Z1 and X2. So intersection of Z1, let me just draw it. Okay, this is the one. Okay, intersection of Z1 and X2, that's the intersection. And origin of frame 2. Okay, where's origin of frame 2? This is exactly the same, no matter which axis, that will always be 0. Okay, that's that. And lastly, okay, let's look at, after this, I will expect you to do your own exercise and to solve through all the other examples on your own, okay? So I will give it as a quiz for you to submit. I cannot ask you to submit at this time, but you work on it, but you can submit anytime, and I put the deadline set by the university after 1 month since, I think last week. Yeah, after 1 month since last week. That means 3 more weeks, the deadline of the submission. But if I were you, you better work on it and submit it anytime that you can. Okay? Otherwise, your work will pile up because all the other courses will also be asking you to submit during that time. Okay? So now let's go to joint 3. So okay, let's look at theta 3. Okay. Now, D3 is the one that is a variable. Okay. So this one moves up and down like that. So let's look at theta 1. No problem. Theta 1. About Z2. Okay. So Z2 is that where you are translating, where you are moving from X2 to X3. Okay. We are looking at theta 3. About Z2 from X2, where is X2? X2 to X3. X2 and X3 are parallel, and so there's no rotation about Z2. Okay? No rotation about Z2. If you look at that, this is Z2 rotating like that. And it rotates like that. I mean, it rotates in case there is an offset angle, because now Z2 does not rotate. Is looking at how theta x, how x1, x2, and x3 are offset in terms of the angle from each other. But in this case, there's none. So that is 0. Okay. Again, theta 2 is a constant at this time, and it is not a variable. Okay. So now we finish. Theta 2 is 0 because x2, and x3 are parallel. So x2 and x3 are parallel. Okay. Next, alpha 3. Alpha 3 about x3. Where is x3? That's x3. About x3. From Z2 to Z3. Yeah. From Z2 to Z3. Again, Z2 and Z3 are coincident. There's no rotation about x3. And because this alpha 3 is a constant, it's not a variable, and so it remains 0. Okay, that's 0. Next, D3. Okay, along Z2. So along Z2 from origin of frame 0, frame 2. Origin of frame 2 is this one. Okay, let's draw it. So let's make it blue now so that you can see it. So origin of frame 2 is this one. Okay, to intersection of Z2 and X3. Intersection of Z2 and X3 is this one. Okay, so now from here to there along Z2. So Z2 from here to there along Z2 in that direction, that's positive. And now this distance is D3. And because it's not a constant, it is a variable, we don't write how much is it now, but because it's changing, we put the variable there, D3. So we're done with D3. So next, lastly, you have A3 along X3. Where is X3? This is X3. That is X3. And now, from intersection of Z3, Z intersection of Z2 and X3. Intersection of Z2 and X3, that's the intersection. So let me draw again. Okay. This is the intersection of Z2 and X3. Okay. And origin of frame 3. This is also the origin of frame 3. They're both coincident. It doesn't matter. That's 0. It doesn't matter which axis it is. That's 0. Okay. Finished. Okay. Now, again, we're going to do the transformation matrix. We know that this is the total transformation matrix. And we just substitute things there. There's a total transformation matrix. We substitute accordingly. So, for example, your A0 transformation from 0 to base 1, okay? If you substitute all these parameters here, A is 0, A is 0, A1 is 0, A1 is, both of them are 0, and there's a D is D1. So here is 0, but we're going to put D1 because we have a D1 there. So this one should have a D1. D1. Okay, I will draw something that is a D1. Okay. Now the rotation. Now the rotation, you have cosine theta. Theta is, that's theta 1. Yeah, okay, that's correct. And here your alpha is 90 degrees minus 90 degrees. Cosine of alpha, cosine of 90, no matter positive or negative, that's 0. So now this is 0. So that's 0 and that's 0. So we have 0. Sorry. Undo. So this is, that's 0 and that's 0. Okay, next you have sine of minus 90. So what is sine of 90? That is what? 1. Yeah, sine of minus 90, that's negative 1. Yeah. So now this is sine of theta. So that's why this is negative 1 and this sine theta. So that's negative 1 and this sine theta. And so that's correct. Okay, again, this is sine of minus 90, that's negative 1, and this is negative 1, it becomes positive, so cosine of theta. Okay, so this is correct already, as we said, and this is correct at 0 because there's A0, A1 is 0. Okay, everything is correct. So now, oh, sorry, here at the bottom, that's 0, correct? And this is alpha, sine of alpha, sine of minus 90, that's negative 1, that's correct. And this cosine of minus 90, that's 0. Okay, everything is correct. Okay, so now cosine of theta 2, you have cosine of theta 2 here, cosine of theta 2, so this is cosine of theta 2, that's correct. Now you have your alpha, cosine of alpha, that's 90, so this is 0 and that's 0, so that is 0. Cosine of 90 is 0, so this is 0 and that's 0. Okay, here sine of alpha is 1, so this is 1, so that is sine theta 2. And this is 1, so negative sine of 90, that's negative, and then that's correct. So now because your A2 is 0, so that's 0 and that's 0, that's 0 and that's 0. But you have a D2 there, so D2 is correct. The bottom you have 0, sine of alpha is 90, that's 1, and cosine of alpha is 0, that's correct. So next, the third joint or the third link. So we say that again, in this case, your theta is 0. So here, this is cosine of 0, so that's 1. So this should be 1. Cosine of sine of 0, that's 0, so that's 0, and the other one is 0. Okay, now your alpha is 0. Cosine of alpha, that's 1. And the sine, this is sine of alpha, sine of theta is 0, that is 0. So this is 0. Okay. Cosine of alpha, that is pi over alpha is 0, that's 1. But then cosine of theta, that is 0, that's 1 also. So it becomes 1. Okay, this one is sine of alpha. Alpha 3 is 0, so that's 0. So that's 0. So sine of alpha, where alpha is 0, that becomes 0 immediately. The sine of alpha also, that's 0, because that's 90 degrees. Cosine of alpha, that's 0, that's 1. So that's 1. And your A is 0, so 0, 0, so that's 0, 0. And D3 is a variable, so it becomes D3. And this D3 is a variable, this D2 is a constant, this D1 is a constant. So if you keep on multiplying, then the result will be multiply A01, 0A1, post multiply with 1A2 and 2A3, the result is this. This is a simplification. If you multiply this times this and times this, the result is that. Okay? And that's it. For the rest of the things, have to clear everything here, clear drawing. Then you go through each of these exercise and do it on your own. I will give you the quiz later, and I will submit a quiz. I mean, I will submit a question, and then I will also, Blackboard, I will give you a quiz, and you submit it after 1 month. Okay, thank you very much. And I upload this video in YouTube, and then kindly take a look at it. Go attend your lecture in YouTube, and then submit the assignment or the quiz after 1 month, after, 3 weeks from now. I will set it 3 weeks from now. But if I were you, again, you please submit it as early as you can. Thank you. Now I have to